Welcome back to the lab. Today we're going to take an important step forward in our project. We're going to turn this board into a UPS. Before we do, if you're working on an awesome project of your own, you could win one of our design sponsorships. Check this out. Maybe you want to control something connected to mains, but don't know how to do it safely. We can help with that. That's what this contest is all about. Okay, that sounds great. Here's how to enter. Tell us about yourself, tell us about your project, tell us how we can help. Best of luck. I hope you're as excited to work with me as I am to you. So thank you for watching EEforEveryone, and I cannot wait to hear about your next great project. Okay, where did we leave off? Right, we're building a UPS today. I'm pumped. In our last video, we were taking some sweet close-up shots of the PCB assemblies that we received after they were assembled. We were taking a look at some of the solder joints and the quality of the fabs themselves. We talked through some lessons learned, our experience with using all PCB, and ultimately by the end of the video decided whether or not we'd use them again. To remind you of some of that context here, the reason why we hired an assembly service in the first place was simple: time. Each one of these boards has 364 surface mount parts on the board. This creates almost 900 surface mount solder connections. That'd probably take me between 20 to 30 seconds per solder joint, factoring in some time to be flipping through part bags, placement, rework, cleaning, etc. But this means that we'd probably be spending between 5 and 7.5 hours just soldering parts onto each and every one of these boards. Assembling 5 of those boards might have taken us around 40 hours. Yikes! That's a lot of time to sink into these boards. Speaking of soldering, let's do that. We made a handful of mistakes when having all PCB assembled boards with regards to the parts on the BOM and the footprints on the board. One part was ordered just with the incorrect package width, which was just due to me misreading the datasheet. Some resistors were ordered with 5% tolerance instead of 1%, which just meant that there's some parts that we needed to have them leave off the board, and then we're going to populate them here with the 1% part. After a brief stop with populating the couple surface mount parts that we need to do, this is when we began the board level reworks. We hadn't discovered what reworks were required yet because we haven't powered on the board yet, but as we continue to assemble our future boards, that's what's going to become our process. Essentially, what we're doing is everything that doesn't have a large component height, we're soldering that onto the board first. We have about 100 through-hole components to put on the board, but these parts are all pretty simple. The parts that we need to install they're primarily headers, through-hole electrolytic caps, diodes. They're easy to do in bulk because there's a lot of the same component, and each of these components kind of only fit in one spot, so it's pretty hard to make a mistake. Stick the leads through the board, bend the leads appropriately so they're stuck in the board, clip them off, solder them in, good to go. In retrospect, some of these parts truly benefit from the through-hole package, but for some of the others, we really should have used surface mount parts and had the assembler put them on the board. Like these electrolytic caps, there are surface mount variants that we could have used and still paid about the same amount of money. So we're going to take the connectors, capacitors, diodes, and get those on the board. With this complete, we just need to bend a few leads for the transistors in order for them to fit on the board properly. Looking back, we could and maybe even should have had our assembler do more. We should have designed our boards to make it more economical to have them put on more of these components, but really I don't mind a few through-hole components to put the button on this design. It gives me a good taste of the assembly process without consuming my life for 2 months. I do enjoy soldering, after all. So now that we're done with that, there's just some heat sinks, inductors, and wow, was that it? Our live stream archive shows a time of 4 hours and 35 minutes to go from a bucket of parts to a board screwed into a computer case. Given that we're typically operating somewhere around 60% efficiency while streaming, that means that if we did this from start to finish with full focus on the assembly, we probably could have finished this in around 3 hours. So that would be about 3 hours per board to populate the through-hole parts in the board. Not too bad. To finish off this video, there's one more thing that I'd like to share with you. After we assembled this board, we did a brief power-on test. We were simply too excited for our own good, rushed in blindly and saw what happened. After all, what's the point of having an assembled UPS prototype if you can't turn it on? So we did a heavily current limited power on test, and that was just looking for some gross faults and basic functionality of the unit. Power ground faults, voltage rails being set incorrectly, that kind of stuff. Our software requires some serious tuning before it will actually work. Just wanted to make sure that everything looked about right. Well, despite these issues, our UPS is really coming together. We've done our first power on test and it survived. We're well on our way through this awesome project, so subscribe to be notified for our future videos where we'll discuss how we organized our code to make it more sustainable and dive into the general bring-up testing that we need to do on our first board to verify that everything's operating as expected. I think that this UPS project is great, and I'm very excited to iron out the wrinkles that we may find and get this thing working as intended. If you're excited too, let me know by hitting the like button on this video, hitting us up on Twitter, or leaving a comment letting us know what you enjoyed. Most of all, I hope that you learned something great today, and I hope to see you again soon. Thanks for watching EE for Everyone, and thank you for staying till the end. Bye!